So this is Chapter 7, which deals with perfect competition. And you'll have to forgive the little bit of writing I've done here, but this is version 2 of this lecture. So let me review a little bit about what I was trying to say here. So what we had done in the previous chapter is we had talked about what makes a firm what motivates it to do what it does, and that the motivation for a firm is that it is trying to maximize profit. And the way that we understand profit is that profit equals total revenue minus total costs. And that revenue is the price times the quantity. So then what we had done in the previous chapter is that we had talked about then basically how a firm thinks about its costs and how it tries to minimize its costs. And how it then makes, in part, how that contributes in part to the profit. But now what we need to deal with is the price and the quantity. And the thing is that it's different across different firms. Different firms are going to have different price structures and different levels of quantities of production. So you can imagine this existing, that there being sort of a spectrum of different types of competition. And on the one, we could have perfect or pure competition. And on the other end of the spectrum, we could imagine there being no competition. That no competition situation is the situation that we'll look at in the next chapter of a monopoly. We're going to start on this end of the spectrum. What makes a firm be on either end of the spectrum is in part a reflection of how many competitors they have, and that in turn reflects their pricing power. Under this scenario, under perfect or pure competition, what we're looking at in this chapter, there are many firms. These firms are what's called price takers. As I write out over here, they take the market price as given. How is that market price determined? Simple demand and supply for the product as a whole. Let's pick a perfect competition kind of market. Now, let's just say water, right? Buying bottled water. Well, what I'm trying to argue here is that Menehune or Costco or anyone doesn't get to really determine their prices for water. Rather, each firm is competing in a market where there are lots of consumers, and that gives us a market price, and they just have to take that price because there's so many other firms there. This is in contrast to what we'll look at in the next chapter, where there is only one firm. That one firm gets to make the price. And that's how we're going to start to differentiate things. So in this chapter, we're going to look at firms on this end of the spectrum. In the next chapter, we'll look at this end of the spectrum. But I don't want you to lose sight of what we're doing here overall, is that we're trying to still think about how firms make decisions to maximize their profits. Well, here we go, right? If we look at that spectrum, then, which is on this slide here, again, just to review, you would have pure competition on this end of the spectrum, pure monopolies on this end of the spectrum, monopolistically competitive on this end of the spectrum, and oligopolies on this end of the spectrum. So in terms of competition, the most competition exists at pure competition. Then there's slightly less competition with monopolistic competition, even less competition with oligopolies, and no competition with the pure monopoly. What that means is that there's a direct relationship between the number of competitors and your pricing power. The more competition you have, well, I should say, I'm sorry. So directly, let's just take this out. I didn't mean direct. I should be precise here. That there's an inverse relationship. Inverse relationship between the number of competitors and their pricing power. The more competition is, the less pricing power they have. More competition translates into less pricing power. Okay. So let's then look at this specific kind of firm. The perfectly competitive or pure competitive firm. I'll use the terms interchangeably, perfect and pure competition. Unfortunately for you, I learned it as perfect competition. I've done it as perfect competition all my life. And so the fact that the author decided to say pure competition, it's not the reason why I wouldn't pick a book. And just know that I'm using the two terms interchangeably here. What makes a firm perfectly or purely competitive in its industry is, first and most importantly, that there's a large number of sellers. And these sellers are selling the exact same product, or what we would call a homogeneous product. That these firms are price takers. They take the market prices given. That would mean, right, that in the market they take that market price as given. These firms can easily enter and exit the industry. And the demand for their product is perfectly elastic. Which basically means for this kind of firm that what we're implying here is that the consumer demand will be completely eliminated if it's not at this price. Elastic would basically mean that there would be a infinite change in the quantity demanded for very little change in the price. We don't talk a great deal in this book about elasticity, at least in this class, simply because we'd run out of time for everything else. If the term elastic bothers you, don't worry too much about it. Just think of it as this: that there'd be a very large change in the quantity demanded for a very small change in the price. Which means that as we put this together, that for the individual firm, their demand curve is perfectly horizontal. Because as long as they're charging this market price, let's say it's $131, they can sell as little or as much as they want. Each time they sell the product, they exactly bring in the price, which would be the same as their average revenue. And as you can see then here, Every time they sell one more unit, they bring in $131. And it changes at a constant rate of $131 for each unit sold. And that would be these equations then here, right? Where the average revenue would be equal to our total revenue divided by the quantity, which would be the same as the price, which was in this example back here, 131. The total revenue then would just be the price times the quantity. So let's say I sold 15 units, then at $131 a piece, I'd be able to calculate the total revenue. And then this would be my change in my revenue every time I sell one more unit, which is the same as the price in this case. What then becomes important for this perfectly competitive firm is, are they going to produce or not? If they are going to produce, how much do they produce? And then what would their profit levels be? These are three very important questions that we will deal with in all four of these different types of firms. The monopoly, the oligopoly, the monopolistically competitive, and the perfectly or purely competitive firm. Are they going to produce or not? How much are they going to produce if they do decide to produce? And then what would their profit levels be? Well, part of this can be looked at from a table. A table that we've already seen how to think about the costs, right? In this case, this would be my fixed cost divided by my quantity. In the case of my average variable cost, it would be my total variable cost divided by my quantity. And my average total cost would be my total cost divided by my quantity. For my marginal cost, it would be my change in my total cost over my change in my quantity. Then I would have my profit, or I'm sorry, my marginal revenue. And then for my profit or loss, what I'm doing here is I'm taking the price times the quantity, and I'm subtracting, I guess from the information that we have, the average total cost times the quantity. So if the price is 131, then I'd be, for let's say row 9, what I'd be doing is saying 9 times 131, sorry, getting out my calculator here, would be equal to $1,179 in total revenue. As for the total cost, it'd be now 9 times 97.78. So now I have profit equal to total revenue minus total cost. Profit, which I'm just using as the pi symbol here, being 1179 minus 880.02 for 298. .98, which the book decided to confusedly round to 299. I say confusedly because if you'd solved this and you saw 299, then you were pretty frustrated because you're like, where's that 2 cents? But we could imagine that to solve this column, I could do that row by row by row. All right, and I should say this here, right, is that what I would be doing here, if I wanted to think about how much this firm should produce, what I want to do is I want to follow this. I want to follow a rule. A rule which is kind of confusing on this slide here. It's not. It's where marginal revenue is equal to marginal costs. We're pretty darn close. So what I'm doing here then is comparing these two. Here's the question, like, why is that the case? Why is that the case that so here, this is quite important here, what I'm doing here. Here's what I'm suggesting. That the profit maximizing rule or basically how much to produce for any firm is given by setting marginal revenue equal to marginal cost, or at least getting the two very, very close to each other. This, again, is how much extra revenue I bring in for every unit sold. This right here is the extra costs to producing one more unit. Let me ask it to you this way. What would you do if you were a firm and I told you that the marginal revenue exceeded the marginal cost? The revenue generated by selling one more unit was greater than the costs to selling one more unit. You can already get a sense of what we're getting at here, is that this firm would produce more. Because the cost of making one more unit is less than the revenue they have going into it. They get from going into it. If instead the marginal revenue was less than the marginal cost, every time the revenue produced one more unit, they'd bring in less money than they were spending to make that unit. This firm would make less. But now the question then leads to, what does this activity of making more or less, what impact does that have? Well, look at what happens here. The marginal revenue is always the same, because for the perfectly competitive firm, it's a price taker. So this never changes, but this does change. Why is it changing? A very important question of why it's changing. The marginal cost is changing as we make more because the workers are becoming initially more productive. That causes the marginal cost to fall. And then they're becoming less productive. Remember that from two chapters from the previous chapter. That we understood workers as having differing productivities based on how many workers they were working with and how much capital they had around them, and that initially workers became more productive. Well, that would mean that the labor cost initially, if they're becoming more productive, that would mean the labor cost in each unit is becoming smaller and smaller. But then the workers become less and less productive, meaning it takes more labor to produce each unit. This is a very important rule. This activity then of producing more will cause the marginal cost to rise. This activity of making less will cause the marginal cost to fall until these are equal. This to rise until they are equal. That's the important rule here. So, if we take that forward then, and we look then at this graphically, that graphically what we're saying here is that I want to find the point where the marginal revenue, which is this straight line here, is equal to the marginal cost. Now it's equal over here. I'm sorry, I take that back. I was going to say it's equal over here, but it's a different curve. This is determining how much should be made, 9 units. if we were to start to shade in some different colors here, the total revenue would be this large rectangle. Total revenue, it'd be P times Q, or the 131 times the 9. As for my total cost, it's equal to ATC times Q. ATC at 9 is right here, 97.78. So my costs is this somewhat smaller rectangle. With the difference between then my revenue and my cost being my economic profit, which is maximized where marginal revenue is equal to marginal costs. I don't know why they're saying a dash here. It's an equal sign. Now, it may be the case from time to time where the firm actually may still produce even if they're making a loss. Let's look at what a loss would look like. What a loss would look like is, set this up here, P and Q. There's my demand equaling my price equaling my marginal revenue. There's my marginal cost. Well, let's say that my average total cost curve is right there. Which would mean if I'm setting marginal revenue equal to marginal cost, which you should be doing, then, sorry, this is how much I'm going to produce. Let's call it Q star. But that the costs to making Q star are way up here. So now my costs, which are this larger square, exceeds the revenue, which is that smaller square. Would this firm produce? It actually requires more information from us. It would require that we know where the average variable costs are. The average variable costs, if you remember from the previous chapter, are less than the average total costs. Let's say that they're right there. The difference between these two is the average fixed cost. If the firm were to go out of business, then the loss would equal the fixed costs. But look at what's happening here. This firm at producing Q star is able to make up all of the variable costs. I'm sorry, not ATC, I'm sorry. AVC. Is able to make up all of the variable costs and half of the fixed costs. So their losses would actually be less by producing Q star. Again, this is the AVC curve. This is the ATC curve, the difference between the two of average total cost and average variable cost is the average fixed cost. This firm, by making Q star, has got about half of the fixed costs covered. So they would actually be minimizing their losses. And that's exactly what we see here. They will still produce as long as the price is greater than the average variable cost. But if the price is below the average variable cost, this firm will not produce at all. Because if the firm produced where the price was less than the average variable cost, then the loss would be all of the fixed cost plus a portion of the variable cost that it's not covering now. So that firm would go out of business because at least then they'd get rid of that part. And we can then kind of see that kind of discussion going on here. Right? Is that this kind of firm, what we can do is we can think about how their revenue compares to, their marginal revenue compares to their marginal cost. And what we can do is we can think about how is that loss again being minimized. Would this firm produce at 9 if the loss was negative 151? Well, they would, because the price, which is equal to 81, right, is bringing in more revenue than the firm otherwise would have had, right? Or I guess in this case here, this firm, right, the price here is less than the average variable cost. This firm will not produce 9 units. But would they make 6? They would. Would they make 2 units? If that's where the marginal revenue was equal to the marginal cost, or if that's where I could find that they were closest, would they make 2? Right? That would be a situation where they'd actually be contributing to their losses even greater. And the picture I drew is what we kind of see here, right? Is that the firm in this case, if we were talking about 6 units of production, that at 6 units of production, they would make that amount because the revenue brought in would exceed the cost of that unit. And that's what we see right here. That this loss, because it's covering the difference between these two, that means the loss will only be a fraction of the fixed costs. And then firms can shut down. Firms will shut down when the price is less than the average variable cost. In this case, this firm would choose to shut down at 9 units, certainly. They wouldn't make 8. They wouldn't make 7. They wouldn't make 6. They wouldn't make 5. They wouldn't make 4. They wouldn't make any of these. Because in all of these cases, the revenue brought in is less than the costs. How do we know that this firm would shut down? Well, look at it this way. Again, if it shuts down, the loss is equal to $100, or the total fixed costs. Look at all these numbers. Outside of shutting down, where the loss is 100, all of these numbers are greater than 100. That firm is better off by shutting down. And that's exactly what we see here. A firm that's shutting down because the revenue brought in, where marginal revenue is equal to marginal cost, which is right here, I then go up and down, and I see that this firm wouldn't even make the variable cost. So again, first thing you're doing is you're finding where marginal revenue equals marginal costs to know how much the firm would produce. Then the question is are they going to make it? In this case, they're not going to make that because at 5 units of production, the revenue brought in isn't even enough to cover the variable costs. And if we bring that forward then, what we start to see is that these firms, if we look at the supply schedule here, then I can start to look at then how all of the firms, and this one firm in particular, at the different prices, how much they will decide to supply and what their profits and losses would be to doing that. And you can then add that up for an entire firm. But here's what you see, is that the supply curve is the same as the marginal cost curve at all points above the average variable cost. The supply curve for firms, for the perfectly competitive firm, is the same as the marginal cost curve at all points above the average variable cost, which is right here. At this point, they would shut down. But at all the points above the average variable costs, or basically my marginal cost curve, now I've got my supply. So what that does for us is it then helps us understand the answers to these questions. Let's start off with the first one. Should the firm produce? Well, this is kind of getting at the shutdown point. The price had better be greater than the average variable cost. How much will the firm make? It's going to make the amount that represents where marginal revenue is equal to marginal cost. Will this firm make a profit? Well, I guess that depends. In this case, we need to compare total revenue to total cost. And if total revenue is greater than total cost, then there'll be a positive profit. If total costs, on the other hand, are greater than total revenue, there'll be a negative profit, but this firm may still produce so long as the price is greater than the average variable cost. And then what we can do is add that up across all firms. You would simply add that up then in terms of their supply. If there's a single firm, and if there's then 1,000 firms, I would get 10,000 units of quantity. And then I can have my market demand. And what that does, I actually don't like the way that this looks here. Let's look at it this way. Let me redraw this. In the market for water, then, there's a demand curve and a supply curve, where let's say that the market price is $1.50 a bottle. Then what we're saying is that in Tom's water, the water company I'm starting, is that I take that market price as given, and now if I'm looking at my individual as a firm's market, remember I have a perfectly elastic demand curve, which means I can sell as little or as much as I want, so long as I charge $1.50. Now I made this a small d for my own purposes so that I can distinguish demand for Tom's water, which is an individual firm's water, from the entire market for water. Now I've got my marginal cost curve. And I'm going to make Q star. And that's exactly what we're seeing here then. With the only differences in terms of notation being that for the single firm, what they did is they added the average cost curves. And that for the industry, the picture that I had on the left-hand side here, for the industry, all they added was a designation that the supply curve is equal to the sum of all the firm's marginal cost curves. Now, you shouldn't forget that these firms, again, get to decide whether they want to stay in this industry or not. And that has an impact on things, because if firms are losing money in the short run, well, eventually they'll have to go to business if they keep losing money in the long run. And if firms are making crazy money doing the job that they're doing, eventually more firms will enter that market because they'll realize, hey, that's a really good industry. So what ends up happening is that because there's easy entry and exit, it drives the prices to the long run equilibrium. And if all these firms are facing the same costs and they're all charging the same price, then firms that are making profits are going to either expand or more firms will enter. Firms that are losing money are either going to get smaller or go out of business. And what we then see is that more firms entering the markets eliminate the profits that exist. Exit of firms, or firms getting smaller, is going to eliminate the losses. And what happens is that in the long run, the long run situation is that there's no profit to be earned. That what happens here that let's make this firm earn money. So I just drew this out as if this firm is making money, because what we would do is we would set the MR equal to the MC. They would make that amount and charge this price. This firm would make money in the amount of that. because firms are making a positive profit, that leads to entry. How do we understand entry in this picture? We understand it as a supply curve shifting. Drives the price down. Yeah, yes, I was a little bit liberal here and kind of doing it like that, but I didn't want to have to draw it multiple times. But the entry shifts the supply curve to the right. And in so doing, drives the price down until the profit is completely eliminated. And that is exactly then what you see on this slide here. Is that you see there being a profit that in the first stage exists, more entry being represented by the supply curve shifting to the right, driving the price until it's equal to the revenue. Entry then is eliminating the profit, just as exit is eliminating the losses. And we can just draw that out really fast so that you see that going on as well. So here would be a firm where they would set their marginal revenue equal to their marginal cost. So they would make that amount. This firm would continue to produce because the price is greater than the average variable cost. So they're not going to necessarily go out of business right away. But eventually, firms will go out of business. Eventually, firms will get smaller. The loss leads to supply shifting to the left. And it will shift to the left until the loss is completely eliminated. And what that means for us then for the overall industry as a whole is that it means that the firms are not going to, their entry or exit is not going to affect the costs. It doesn't make resources cheaper or more expensive based on how few or how many firms are there. As long as we're in a constant cost industry. But we wouldn't think that that'd necessarily be the case for all industries, that we could imagine some industries existing where if there's specialized labor or the resource is one that only your kind of firm would demand, well then that might be a situation where you could actually affect your cost by having there being more firms or not. But if we have a constant cost industry, the supply curve would then be completely horizontal for the long run supply. Again, this is different than short run supply, which is actually, again, just the marginal cost curve. What this is here is an industry is saying if there's constant costs, then the costs are not going to be increasing or decreasing based on how little or how much the firm makes. If it's an increasing cost industry, then what we see is that the costs, because they're going up, the firms would have to demand higher prices if we're making more and more stuff. So the supply curve, as a result, is upward sloping. The decreasing cost industry, we don't tend to see that too often, so let's not deal with it, and you're not going to be tested on it. But what we see here then is that a notion of efficiency starts to get achieved in the long run because these firms are setting their price equal to their marginal cost, or again, the marginal revenue, which is the same as the price, being equal to the marginal cost. And that these firms are also being productively efficient because they're making sure at least the price is equal to the average total cost. Or in other words, that we're not getting a profit, where profit could be seen as a measure of inefficiency. Now, the final comment that can be made about these kinds of firms, at least for this class, which again is just kind of an overview of all of economics, is that what is nice about perfectly competitive or purely competitive markets is that because there is so much competition, you get a lot of automatic adjustment to changes in the technology, changes in the consumer tastes and preferences, and even in terms of the resources that are provided to these kinds of firms. These firms, because they are so competitive, have to change quite quickly to meet these kinds of demands. In terms of the invisible hand, they're just saying that then the market participants respond, that the sellers are responding to what the sellers want.